So hello again. This is a continuation of the previous video, which was about finding the centre of mass of a hemispherical shell. Okay, so we were just finishing off here. So we had little r tending to big R, and so this is the fraction we got when we replaced little r with big R. We have 3 times 4r to the power of 4, r cubed. And then on the bottom we've got 8 times 3r squared. And so we've got 3's cancel, 4 cancel with the 8, r cubed cancels with r squared, and we get a half r. So the centre of mass of a hemispherical shell of radius r is a half r from the centre. So that was the method of finding a centre of mass of a hemisphere, a hemispherical shell, without using calculus. Now, it is possible to use calculus, and I'll show you how to do that in another video. You could have a go yourself. There is if you go to chapter or exercise 3b, I should say, on page 98, you see the challenge question is to do exactly that, and I will put it on a video in due course. But we could continue and think of other shapes, other three-dimensional shapes, which are shells, so two-dimensional objects which are three-dimensional, 2 dimensions in 3 dimensions. The next one to look at would be a cone, and to find that the centre of mass of a cone, so that's a conical shell rather than a solid cone. A solid cone we would do by calculus, but the conical shell we would do by an argument, and we can find that argument on page 93 of the Further Maths 2 book, example number 11. So I'll just mention that now. So here is the cone, and it's a conical shell. So what we do here is we divide it up into small triangular shapes on the surface like that. So if we can go all the way around the cone, we have many of these triangles. And we know if we approximate each of these, which are slightly curved, but if we approximate them to a triangle, because they're all going to be very thin, so they'll be very close to a triangle, then we know where the centre of mass of a triangle is. It is 2/3 from the apex, so it'd be 2/3 from O down to about there. So all of the slices that we are dividing up the cone will have the centre of mass on that at that point. So you can imagine drawing a circle around, cutting the cone, section of the cone with a circle here, and the centre of mass of each triangle will be on that circle. So we can say, therefore, the centre of mass of all those triangles are on on that circle. So the centre of mass of the whole thing, the whole bit which is the conical shell, will be the centre of mass of the circle, which is the centre of the circle, which is on the x-axis, and it will be 2/3 from O. So that is the way to find the centre of mass of that, and it's really by symmetry and by knowing the centre of mass of a triangle.